Hi, and welcome back to Unit 2 or Chapter 2. In this chapter, we're going to be covering variables and data types, things that are really important in Java. Let's get started. So understanding how variables work is a really important part of any programming language. Variables are simply memory locations of values. So when we want to store a value into a memory location, we give it a name that we call a variable. Java is strongly typed, which means you have to tell it what the type is of the variable when you declare it. So as you'll see in just a second, if we want to create an integer value, we have to say int and then my age or my value. We have to give that variable a data type. As opposed to loosely typed languages like Python, it's very important for you to keep track of your types. It also helps you in your syntax errors if you are trying to assign a string to an integer or vice versa. It'll get mad at you and you'll end up with syntax error, which is a good way of making sure that your code stays straight. When you create your variable name, it always starts with a letter. I prefer lowercase for my variable names, and I always start with a lowercase letter. It differentiates them from class names, so I can make sure that I know that they're variables instead of a keyword or a class name. You cannot have spaces, but we can use underscores. So you could say my underscore age, or if you want to differentiate between words, so have multi-word variables, you can use what we call camel case, where it looks like a camel. It starts out low with a lowercase, and then every word thereafter is capitalized. So if I was to say my age, my would be lowercase, but age would be capitalized. Capital A, lowercase age, or G. There are different types of types in Java. So we have primitive types and reference types. Our primitive types are our bytes, shorts, ints, longs, floats, doubles, characters, char, and Boolean values. There are 8 of them, and those are our primitive types. Those can be individual numbers, like the number 5 is a primitive type for an integer, which is an integer type. Or we can have the quote, hello world, which is a character array. We can also have reference types. Reference types are objects, strings, or arrays. Arrays are linked lists of objects or lists of objects. Strings are characters that are put together, and objects will be classes, which we'll be talking about in the future. So these are reference types. If you declare something as a primitive type, it may react differently than if you declare something as a reference type. So it's important, again, to always keep your types straight. You can declare multiple declarations in a singular line. So if I say integer to start with and then have height and width, I can say int height equals 5 and width equals 8 or 10 with a comma between them and a semicolon at the end. Because those are both integers, that's allowed. If they were different types, you would have to put them on different lines. In Java, we have the concept of constants. Constants are variables that do not change. They are set once, and that's the only time that they are set, and they cannot be set again. We use the keyword final to reference static, constant values, values that do not change. So if I say value int, or final int length, equals 10, then that length cannot be changed later on. Generally, we refer to static or constants in all caps. It just makes it easier to see that those are constants as opposed to non-static or manipulatable, mutable variables. When we have named a constant, as we did here with our length, they are called a named constant because we have a constant value, 10, and it's named length, so a named constant. A lot of new programmers will use what we call magic numbers. Magic numbers is where somewhere in your code, you're just going to put the number 4, just because the 4 goes there. So I can say how many times I'm going to do a loop, or I'm going to print out the number 4, or I'm going to use the number 4 in some location, but I'm not going to give it a named variable. I'm going to use it as a number, and I'm going to go ahead and manipulate it with a 4, but it's much better to have that named. This works a lot in mathematical operations, where we want to say multiply, your percentage by 4. Why are we multiplying it by 4? Well, because that's our percentage multiplier, that's our unit rate, or that's something like that. Give it a name. Don't just make it a magic number that just, so when somebody else looks at your code, they'll know what that 4 reference is. When we talk about scope in Java, your scope of your code is going to be a singular block of code contained within curly braces. Inside of your code, anything that is declared in that block is in that scope. So in this case, I have a public void main. So I have a main function, and I've declared an x, y, and a z. My x is they're all integers, and I'm using the values from other methods. Okay, fine. The value x that exists in main is not visible outside of main. So in my function calculate result, or in my function calculate another result, the value x doesn't exist unless it's passed in as a parameter. So you can have variables that have the same name in 2 different functions. However, if you have the variable with the same name in the same function, you will get an error, unless you're intending that because you want to change the value. We call that scope, the visibility of a variable within a block of code. So if you are in your private int calc result, the variable x, y, and z from main are not visible at all. You can pass a value as a parameter. So in my private int calc another result, I can pass an integer x and then use it therein. That is a completely different variable than the x that is up in my main. Even though the one up in my main is using the same value, they end up being the same value, but they are different variables. So really important to keep track of your scope. Each function cannot see variables from other functions unless they're passed as a parameter. So keeping track of your scope is a really important concept in any programming language. When we want to combine 2 variables, they can be variables, they can be objects, they can be strings. It's important to keep them straight. So if your variable is an integer, it is going to be treated as an integer, except if it's being concatenated with a string. If it's being concatenated with a string, it will be treated like a string. So in the 2 examples that I have here, I have a print hello, comma, and then +3 +4. Well, the hello +3 occurs first, so it will go hello +3, and it'll make it hello 3. Then the +4, and it'll go hello hello, comma 3, 4. However, if I put my 3 and 4 in parentheses, the mathematical operation of 3 + 4 will occur before the concatenation. So it'll say hello 7. It's important to remember that order of operations occurs the same in this language as it does in mathematics. Parentheses occur first, so anything within parentheses is going to happen before anything outside of the parentheses. You'll see in this example that we have the numbersprintln class. So my file name is numbersprintln.java. I always include a comment at the top of my files that let me know what the name of the file is, who wrote it, and the date and the description. I'd really like you to include those in all of your files. You can ignore the package for now. It's just used to keep track of things that I have in my generic folder. But you can see that I have my main function, and then inside my function, linearly, procedurally, we're writing down a single variable, billing date, which we're setting equal to 9 because we're billing out on the 9th of every month. And then as you can see, I have my system out print bills are sent on day, and then it's just a print instead of a print line, so there will be no hard return. And then we have the billing date being printed next. So it'll say bills are being sent out on the 9th of the month, all on one line. This one will end a new line, and then it will print out when the next bill is starting in November. So when I run my code in my debug console here, you can see that it says bills are sent out on the 9th of the month. If I change this to the 6th of the month, I can rerun it, and you will see that now it says bills are sent out on the 6th of the month. One of the pitfalls in Java that we run into is trying to remember that a variable can only hold one value at a time. You may be able to see that if you had x is 10 and y is 5 and you wanted to flip them, you could just make x equal to y and y equal to x and it would be fine, right? But you can't do that in programming because it goes linearly. So if I said x equals y, well, x will now equal 5 and y will equal 5. And then on my next line down, y equals x, well, x equals 5. So y is still going to equal 5 and nothing will have equaled 10. So it's important for you to be able to visualize why x equals y equals x as two different statements will not work in a procedural language, in a language going straight down. It's just trying to remember that variables can only use one value at a time. They can only be assigned one value at a time. In our data demo, we're showing you creating a new non-static variable and a static variable. So we have a non-static variable called a whole number and a static variable called states in the United States. When we run this, it will run and it will say the number is 315 and the number of states is 50. I can go ahead and change my whole number to 240 with a semicolon at the end. And that's fine. There's no problem editing and changing your regular non-static variables. However, if I wanted to come down here and write states in the US and set that equal to 52, I'm going to get an error. You can tell an error in VS Code for a couple of different ways. You can see over here that there is a red. Here it's underlined in red, lots of red. And if I try to run it, it'll give me an error. In this case, the error says on line number 17, so right here where it says line number 17, 3 spaces in, column 3, so 0, 1, 2, 3, there's a problem. And it says final local variable states in the US cannot be assigned because you cannot assign to a static or final variable. So this line does not work. When we start talking about numbers, these are specifically integer numbers as opposed to decimal point numbers, which we'll talk about in a minute. Integer numbers. There are 4 different primitive types for integer numbers. A byte goes up to 128, or from negative 128 to positive 127. It holds 1 byte of data. If you were to hold the value of 128 in binary, you would end up with 8 bits, or a byte, holding that 128. So a byte is 8 bits of binary numbers, and it only goes up to 128. If I tried to store 130 in a byte, it's not going to work. It's not going to let me because there's no way for them to store that. A short is the next smallest value at 32,000, followed by an integer, followed by a long. It's important for you to recognize these are because they're stored in bytes or in bits, and they only can hold so much. There was a time people didn't think you would need more than an integer value, which is a little over 2 billion. 2 billion numbers. But we do. We use long numbers, which is up to 9 quadrillion, which is a really long number. When you store a value in there, or if you cast it to that value, the value will be truncated. Truncating meaning that it just cuts it off. It does not round it. So if you had 5.3 times 10 to the whatever, and you needed to round it off, or you needed to truncate it, the 3 would get cut off and it would just be 5. Truncating does not round. Integers do not round. When you cast a number to an integer, it does not round it. Trying to remember that that's not rounded is really important. We also call that lossy versus lossless, which is the same term that we use in media when we do compression. Lossy versus lossless is whether or not some data, some significant figures are lost. If they are, it is lossy. If they are not, it is lossless. So I'm going to have you go and play with the integer demo a little bit and just try to put in some numbers that are larger than the available numbers for both your byte and your int and your short and your long. Just see what happens and see how the code looks. I'm going to go ahead and show it to you in code, but I want to see you actually go do it so you can feel it happen. What happens when your value starts at something and goes to something else? What if you try to store a value in another value, what's the error that you're going to get? Make sure you recognize those. When we're working with numbers, it's important to keep track of the difference between an integer, a byte, a short, and a long. Each of those have a different number that they can be. So an integer, or a byte being the smallest one, can be between negative 128 and positive 127. Integers, the next one is a short, which is between 32,000, positive and negative. The next is an integer, which is 4 bytes long, or 2 billion and negative 2 billion. And then a long, which is 9 quintillion, 8 bytes. At this point, all of the numbers are set to 12, which is fine. All 4 of those can be 12. But if I came up here and I did 3, 4, 5, 6, and I tried to set my byte to 3, 4, 5, 6, it's going to give me an error. And the error is going to say that it cannot convert from an int to a byte. If I tried to run this now, again, I would get an error. Type mismatch, cannot convert from an int to a byte. That's because this number is an integer and it is not a byte. Now, yes, it can also fall into a short. A lot of times we just use integers as the base, but bytes can only be up to 127. So I can make it 123 and that will be fine. But as soon as I add one more, it'll get angry at me. Same goes for the short and the long. Boolean values are values that can be either true or false, yes or no, 1 or 0, on or off. These are Booleans. Boolean operators are operations or expressions that will give you a value that is either true or false. If I ask, is x less than y, your answer is either going to be yes or no, true or false. And we use Boolean operators and Boolean expressions frequently in coding. The keywords true and false occur in Java. They're lowercase, and we do use them frequently to store a true or false value. You can also use a Boolean expression to reserve a true or false value when we get into loops and when we get into while loops and when we get into if statements. In this case, if we had the operator of less than and we said 3 is less than 8, that would be true. If we said 8 is less than 3, that would be false. Remember also that assignment is equals, but equal to is a Boolean operator that means is equal to. So if I say x equals y, that will assign the value of y to x. But if I said x equal y, that will return either true or false, whether or not x is equal to y. In some languages, you can use an equal sign for both, but not in Java. So you got to remember to keep that straight. You can use greater than and equal to together. Do not use a special character, the one that has the greater than with the equals underneath it type thing. That won't work. It won't know what to do with that character. So it has to be the greater than equal as 2 different characters next to each other, or less than equal. And for not equal to, in Java, we use a not or an exclamation mark and then an equal sign. Some languages use greater than and less than together to say not equal. In Java, we use an exclamation mark or bang or not with an equal. So if 5 is not equal to 6, that would be true. 3 is not equal to 3, that would be false. When we get to floating point numbers, so these are decimal numbers, we refer to them as either a float or a double. A float has 6 to 7 points of accuracy, whereas a double has 14 to 15 points of accuracy. So when you're talking about accuracy, the double is better. When you're talking about requiring less memory, the float is better. So when back in the olden days where we did a whole lot of worrying about memory, you didn't want to use a double if you didn't have to. Double is always the default because that's the more specific value. If you want to make a number a float, so you want to use less memory, you need to put an F, a capital F, after the number. So 23.3 with an F after it will be a floating point number as opposed to a double. And you can see the different values of what can or cannot exist to which decimal place. Again, it's just 4 and 8 bytes, but how many decimal places will it allow you to go to? These are going to be your floating point numbers. When we talk about the data type of a character or a char, a character is a single character, char, C-H-A-R. It is not a string. So hello is not a char. H is a char and E is a char, but hello is not. In Unicode, we can include punctuation and special characters. The ASCII codes will get you A is 65 and a lowercase a is 97. Remember that a capital A and a lowercase a are two different characters, completely two different characters. So if you said character 65 is equal to lowercase a, the answer is no, it's not. It's an uppercase A, and those are two different characters. There's a couple of them here, and there's obviously a list in your book. You can also find a list anywhere online. When we talk about characters, they are the single character, not a string. We'll talk about strings in a second. When you are writing strings, like you're printing out an item or you're trying to make things print out on your terminal screen, we can use what we call escape sequences. So we can create a tab with a /b. We can create a new line with a /n. We can create a backspace, which is a /b. So moves the cursor back one space to the left. We can do escaping our quotation marks if we want our quotation marks within a string. So if you have two quotation marks and you say hello world within those two quotation marks, if you want to add the character of a quotation mark, you can by escaping it, by putting a slash and then a quotation mark or a double, and that would work fine. You can also use a backslash if you want to use a backslash in your quotes in your string by escaping the backslash with a slash. So you do backslash, backslash, and that will allow you to put a backslash in your string. It's really important, especially if you're using terminal sequences to do your user interface, if you want to interact with your users, to use the /t for a tab or use the /n for a new line to make your strings look better. They just make it look better, and it's much better for the user to have it formatted nicely. At this point, we're going to start getting some input from our user. It's great to have programs that, tell you a bunch of information, but most of the time you're going to be getting information from your user. You're going to ask him things, and he's going to tell you things. So you need to ask your user some information. In Java, we're going to use something called the scanner class. So this is an object. Remember how I said you can have primitive types or reference types? This is a reference type. This is a type of object called a scanner. The scanner has methods on it. Its constructor, or its new scanner object, is going to take a system in as its parameter. So every time that you create a new scanner, you are going to write scanner in equals new scanner, and then parentheses system in. Now this scanner in is just my variable name. You can make that scanner input, you can make that scanner goober, you can make that scanner X, I don't care. Make sure that you're consistent though, and that you know that that's a scanner or that's an input device. I call it in because system in makes more sense to me, so I like the word in. You can then use the methods that are on the scanner object, which we're going to show you in just a second, in next line, in next int, so on and so forth. It's important to remember, and this is a pitfall that's in your book on page 77, and the fact that I'm telling you specifically means this is how important it is. On page 77, it refers to when you do next int or next double. It doesn't absorb the enter that you hit. So if you said, what is my age? And I wrote in 13, enter. Next int is going to get the 13, but it is not going to get the enter key, which means it's not going to enter in a next line. And we have to solve that by adding another get your next line after every next int. If you don't, then your next input is going to be confusing because your next input is going to get that enter, and then it's not going to get whatever they entered in the next time. So it's very important when you use a next int or a next line that you always follow it with, a next int and a next double, that you always follow it with the next line, and that will absorb that enter key and keep things moving along. At this point, I want you to go ahead and take some time to create your get user info. This is straight out of the book. You can copy it from the book, but the important thing here is using your scanner class. You will be using your scanner class the entire course, and I don't want you going to the end of the course and not understanding how to use your scanner. I don't even know how that would be possible. You have to use your scanner to get your information from your user. And so this is going to allow you to say, please enter your name, you'll enter your name, and please enter your age, you'll enter your age. So I'm going to show you what that should look like, but I do want you to stop and write it yourself so that you can see it happen in real life, and then you'll understand it better. One of the options that we have is setting our system to use the external terminal as opposed to the internal terminal. If you get tired of using all of this and you don't want to see it all, you can use the external terminal, going up to preferences, settings, and then changing your console. So Java debug settings console, change it from integrated terminal, which is our regular terminal, internal console, which is our debug console, or external terminal. Will allow us to get our user info out of a C prompt or a regular terminal when we hit run. So as you can see, as I hit run here, it'll pop up and it'll say, what is your name? And I can say, Cheryl. What is your age? Say I'm 15. And it says, hello, Cheryl, you are 15 years old. Pressing a key to continue, and it'll close back up. So it was able to take the information we had here and put it in here, concatenating our string. When we use our swing components, we have an object called the JOption pane, which receives input in a swing object. Again, we're not going to refer to too much GUI until chapter 14, but I'm going to continually throw stuff at you just so that you see it and you can choose to write the code at this point, or you can wait until we get to chapter 14. But I do want you to get used to the idea of seeing these swing objects. In this case, it's a JOption pane, which is going to pop up and put in some dialogue, what is your name, and allow the user to type it in. My result is that. So you can look at the different examples between 82 and 87 in your textbook on input and output with a GUI. At this point, we're going to introduce some math with you. Don't let this scare you. The computer's going to do all the math for you. You can perform math operations on your variables or static numbers, but you cannot do math operations on strings because it will concatenate them and then get confused. If you try to do a division, a string divided by a string, what would that do? But be careful when you're combining integers and floating point numbers, or floating points and doubles, or bytes and integers, and make sure that your values will remain in the right type. There is a very special mathematical operation that we call modulus, or mod for short. And modulus, or modular arithmetic, is finding the remainder from a division. If I had 45 and I divided it by 2, I'm going to get 22 with a remainder of 1. My modulus operator is going to return that 1. It's not going to return the 22. It's not a division. It's what is the remainder when you do a division. We use modulus a ton, especially in determining even and odd numbers and doing mathematical operations like that. Remember, mathematics, as with math in Java, is going to be following your order of precedence. If you remember your PEDMAS or your PEDMAS, parentheses first, then exponents, multiplication and division left to right, and addition, subtraction left to right. So in order, it always goes that direction. It goes left to right, does your multiplication, division, modulus first, and then it will do your addition and subtraction. Modulus is in the same category as multiplication and division. Floating point numbers are not precise. So there is an entire description of why this doesn't occur on page 92. But if you take floating point numbers, because when they created code, they did not expect you to be doing floating point arithmetic, everything is stored as binary. It's not stored as decimal. So 2.3 in floating point number is 3 divided by 10, which is not easily resolved as a binary number. So everything is a little bit imprecise. That doesn't mean that it's wrong. It just means that the level of precision may not be where you think it is. So you need to be very careful about comparing floating point numbers. You might want to round them to a certain level before you compare them, or something along those lines, just because the precision of a floating point is not what you expect it to be in code, because everything's stored as binary numbers. In the final demo for Chapter 2, we are going to be working with some math. Math is important to be able to print out information and to do mathematical operations on them. The big one, of course, is modulus, which is to find what is the value of the remainder. In this case, we are going to take 3 values, x, y, z, We're going to set x equal to 15. Y is going to be x plus 10. Z is going to be x divided by 5. And then A is going to be y, which should be 25, modulus 4. So what is the remainder when you take 25 and divide by 4? Well, you get 24, which is 6 times 4, and you have 1 as a remainder. So A is going to equal 1, and we will print out those 3 values. Then we'll set some bank information, and we'll be casting our bank balance from a double into a float. So doubles and floats are 2 different decimal values that we're going to be using. So we can cast it into a float by using the word float in parentheses before the variable, and that will set weekly balance equal to a float. If you left this as a double divided by 4, it would not be able to immediately cast into a float value without some sort of manipulation. And then we'll print that out, and we'll do the same thing with a float value that we're casting into an integer. So, as you can see here, the values that it propped up: 25 for y, z is 5, a is 1, as we talked about. Our bank balance, we took 189.66 and divided it by 4 and cast it into a float, so we got 47.41. And then, of course, for your money, we had 47.82 as a float, and we cast it into an integer, and we got 47. This is how casting will work. It'll turn your float into an integer just by truncating, cutting it right off. It doesn't round it. It just cuts it straight off. When you are performing math on 2 different numbers, the result is always the highest type. So in order of height of types, integers are low. They're the lowest, followed by longs, followed by floats, and doubles are the highest. So shorts and bytes are converted to integers when used in expressions. So that's why they aren't included here. So an integer is the lowest form. If I do an integer operation with a long, I will receive a long. If I do a long mathematical operation with a float, I will receive a float. So a float with a double, I will receive a double. So be very careful with the implicit type conversions when you do math. Java doesn't allow any loss of precision because it implicitly converts to the higher type. That precision, how many decimal places are available, that's where that comes in. You can do explicit type conversions, which we call casting. We can cast to force a type change where you are allowed to lose precision. So I can choose to cast a double into a float. I can choose to cast a float into an int. When I do that, it is truncated. It is cut off. It is not rounded. When you do cast, you precede your mathematical operation by the type that you want to cast it into in parentheses. You can cast from a float into an integer by putting int in parentheses before the value, before the variable on the right-hand side of your operator. A couple of things to remember from chapter 2. First off, if you want to use a float, you have to use the F, the actual uppercase F. If you have a number over 2.5 billion, it has to be a long using the L notation because an integer is too small. The mod operator, the modulus operator, is a percent sign and is used to determine the remainder. Don't divide and then subtract. It's a waste of time. You don't have to do that. Just use the mod operator to find the remainder. The next line operator does not, you need the extra next line operator to consume the enter key if you're doing a next int or a next double. Don't forget to import your scanner class when you use it. Use the PEDMOS order of operations. Floating numbers are never precise. Equals is assignment, equal is comparison. A character is a single character and a string is an array of characters. And plus is concatenation for strings and everything that is not a number. It's addition between numbers. Okay? So I hope that you understood a lot from chapter 2. Again, this does not discount you read the book. I recommend it highly. If you have any questions, please let me know. If you're watching this on YouTube, you can just put the questions in the chat. And I hope you have a great week. Come back next time for chapter 3.